Okay guys, welcome to our video on domain and range for graphs, and then this is pretty much just an intervention because we're going to talk about two new domains and ranges for square roots and cube roots, but we're going to go back to some old stuff as well. So, domain and range. So first, for our square root function, our domain's actually going to be 0 to infinity, or in set notation, x such that x is greater than or equal to 0 is what it'll look like. And the thing you're looking for is the vertex, the starting point. So that's this point right here at 0, 0. So remember, domain is x. Domain is x. Your range is going to be your y value right here. So your range will also be 0 to infinity because we have a lowest point. And that's what's going for. So vertex. So notice for these square root functions, that is not all real numbers ever. It is never all real numbers when it's just a square root function. All right, let's go to our cube root function. If I look at my domain being my set of x values, so I'm going to go all the way to the left. I get an arrow. All the way to the right, an arrow. This is all real numbers. Negative infinity to infinity. All real numbers. And what we're looking for is two arrows. This is actually also true for your range. So when we have a cube root function, it's going very slowly. It's going very slowly, but it is going down forever and up forever. It's just going to happen real slowly because we have two arrows going on. Nice. Okay, so those are our new functions. Square roots, never all real numbers. Cube roots, always all real numbers. Nice and easy. We've done this one before. Your domain here is what x can be, which is everything but this vertical asymptote that's going on right here. We have a vertical asymptote at x equals 0. So it's going to be from negative infinity to 0, not touching, so parenthesis instead of bracket, 0 to infinity. And what we're looking for is our vertical asymptote, Great. Your range is going to be here. It's going to be also, we have a horizontal asymptote at y equals 0, so it's going to be negative infinity to 0 union 0 to infinity. Because the lowest we go is this arrow down here. Go up, we hop over 0 and keep going up. Okay, when we get to our exponential functions, domain is all real numbers. You should remember this from Algebra 1. We've got two arrows going on, but we do have a horizontal asymptote. So very crucial that you pay attention. There's a lowest point, and it's not actually hitting it. So we have a horizontal asymptote at y equals 0. So these are the functions we have so far. We're going to learn two more before the end of the year. So it's just kind of all these things you got to keep in mind when we're doing domain and range. So we're going to focus a little bit of time on the square root function and the rational function, the ones that have domains that are not all real numbers. So these are what we call restricted domains. And it's to figure out what x can not be. And there's two things. You can't divide by 0, which is our rational function. And you can't have negatives inside square roots. Okay? So for a rational function, I know here x does not equal 0. Because what makes this denominator 0 would be 0. If I have 1 over x minus 2, x does not equal positive 2. Because that's where my vertical asymptote would be. A little bit more complicated. If I have like x squared minus 16, that's the same thing as x plus 4, x minus 4 if we factor. So x does not equal negative 4 or positive 4. We'd have two vertical asymptotes there. Next, radical functions. So if it looks like this, x has to be greater than or equal to 0. Now this is where it's even. So notice before, with the cube root, we had all real numbers. So if you have the square root of x, that is going to have a restricted domain because this little number on the outside, if it's not written, is 2. If you have the fourth root of x, that is also going to have a restricted domain because that would be even. 6, 8th, 10th, all that. If it's 3, 5, 7, 9, all real numbers all the way. Okay? And it's pretty easy to see that on Desmos. All right, let's go over rational functions. So here, what is the domain range of 2 over x minus 3 plus 1? So what I'm going to do is head to Desmos. Blah, blah, blah. So y equals 2 divided by x, 2 divided by x minus 3 plus 1. Great. I can see that I have a vertical asymptote, what makes the denominator 0, which is x equals 3. So I can already tell you negative infinity, comma, 3, which comes from here, union 3 to infinity. Or we could just simply say x does not equal 3. Range would be your horizontal asymptote, which remember comes from that k value, y equals 1. So horizontal asymptote is going to be right there. So negative infinity to 1, union 1 to infinity. So y does not equal 1. So if I look at my next question, it says, what is the domain and range of f of x equals 2x minus 5? I see this x minus 5, and I know my vertical asymptote should be x equals positive 5. So a is out because that's negative. B is a maybe. D is out because that's negative 3. D is out. Sorry, I said D. I meant C is out because negative 3. D is out because positive 3. And if I look at my range, I have a positive 3, positive 3. I like answer choice B. All right, so for the advanced kids, this is the next question is actually super important, especially if you're going into pre-cal AP next year. So it says, what is the domain range of x squared plus 2x over negative 4x plus 8? So this is a special function. We're going to go ahead and graph it. Y equals x squared, oops, hold on, let me hit a fraction first. Divide x squared plus 2x over negative 4x plus 8. And we get this weird looking graph going on. Great. What makes negative 4x plus 8 equal to 0? Let me do this in blue, actually, because that's my vertical asymptote. If I just go ahead and solve this, I get negative 4x equals negative 8. X is equal to 2. So my domain is negative infinity to 2, union 2 to infinity. And that's just because that's what makes that 0. Your range, notice your graph doesn't have like a nice horizontal asymptote. So what you're going to do is just click on the graph, and you're going to try and find the lowest and highest point of each part. So I can see that for this second part, the highest y value, I'm going to be working with the point, and I'll round to the nearest tenth. Hold on. My Notability quit on me for a quick moment. Let's go back here, pull up Desmos. So I know my highest value right there. We're going to go 4.83, comma, negative 2.91. And my lowest point, I want to zoom in just to make sure I get absolute lowest, which is that one. It's going to be negative 0.828 and negative 0.086. All right, so what I'm going to do now is I know my range starts from negative infinity on that one part, and it took this point, the negative 2.91, and that's the highest part of that smaller moment. So my graph did something kind of like this. And this is where that other point lived, 4.83, comma, 2.91. Or negative 2.91. I want that negative 2.91 there. This point has negative 0.828, negative 0.086. So we're going to do union, negative 0.086 to infinity. Not the easiest question in the world, but not impossible. You do get a calculator, so you're just kind of looking for your y values that match there, okay? Okay, next up, we got what is the domain and range of y equals square root of x plus 4, and we're going to do this pretty quickly. I'm going to go fast. So I'm going to put this on Desmos. Y equals the square root of x plus 4. Make sure that plus 4 is outside. I can see I have this vertex point at 0, 4, and everything's based off that vertex point. So if you go back to the very front, cool. X value is going to have a bracket, y value is going to have a bracket. So your domain is bracket 0 to infinity, bracket 4 to infinity, because it's going up and to the right. Great. The second you see a cube root, don't do anything on Desmos. You're going to pick all real numbers, and you're going to move on. So because you got that little 3 there, it's all real numbers. Now, if you do put it on Desmos, not a huge deal. So you're going to do y equals, scroll all the way down, cube equals x minus 1 minus 1. You can see it's going all the way to the left forever, all the way to the right forever, up and down forever. All right, last but not least, let's do this last one. There's 2 correct answers here, 1 domain, 1 range. Square root of x minus 4 minus 6. So I'm going to hit the little house. I get the point. 4 comma negative 6 is my x and y value. So I have 4 comma negative 6. It is going to be 4 to infinity because it's going to the right. This would be going to the left. And it is going to be 6 to infinity because this is going up, and this would be going down. So the answer is E. And that's domain range. Smash that subscribe button.